Is screen is visible?
Yes, sir.
Yeah. See the next one. Next problem. Test the convergence of the series x by 1 into 2 plus x square by 3 into 4 plus x cube by 5 into 6 plus x power 4 by 7 into 8 and so on and so on. Now, what is the nth term of this series? Nth term, this is x power 1, x power 2, x power 3, x power 4. Therefore, nth term, the numerator is x to the power of n. Coming to denominator, see the first terms. This is 1, 3, 5, 7 and so on. These are the odd numbers. 1, 3, 5, 7 and so on, odd numbers. So starting with 1 means the corresponding term will be 2n minus 1. And remaining, this is 2, 4, 6, 8. 2, 4, 6, 8 and so on. All are even terms starting with the 2. So this will be 2n. Any corrections? Right? So after writing this one, since increasing powers of x are there, you have to apply first ratio test. You have to apply ratio test. So for that, un plus 1 is equal to x to the power of n plus 1 by, this becomes 2n plus 2, means 2n plus 1, and this becomes 2n plus 2. 2n plus 2. Now the ratio un by un plus 1 equal to, this becomes 1 by x, and this is 2n plus 1, 2n plus 2 whole by 2n minus 1 into 2n. Okay. Now take n terms common. So what is this becomes? This is n square outside. In both the terms, n is common. So this is 2 plus 1 by n, and this is 2 plus 2 by n whole by.
So take 2 also common, sir.
Yeah, it doesn't matter, right? Okay, n square, and this is 2 minus 1 by n into 2. So this n square gets cancelled. Apply the limit un by un plus 1. Limit n tends to infinity. This is 1 by x, and this is 2 plus 0, and this is also 2 plus 0 by 2 minus 0 into 2. Anyway, 4 gets cancelled. This is 1 by x. This is the value of L. Value of L. Therefore, by ratio test, sigma un is convergent if L is greater than 1. So 1 by x greater than 1. That means x less than 1. And divergent if L less than 1. So I will write directly x is greater than 1. And ratio test fails if L equal to 1. That means when x equal to 1. When x equal to 1. Now, one can say, I think this is simple. Okay. When x equal to 1, what is the nth term? Un equal to, what is the nth term? X equal to 1. 1 by 2n minus 1 into 2n. Right? So this is 1 by n common, n square. This is 2 minus 1 by n into 2. Yeah, it's a simple. This 1 by n square is Vn, right? Choose Vn equal to 1 by n square. So sigma Vn equal to sigma 1 by n square is convergent. And what is the limit of un by Vn? Limit of un by Vn, obviously this is 1 by 2 into 2 minus 1 by n, applying limit. So this is 1 by 4, not equal to 0 and finite. So we are not applying any Rabee'S test here. Okay, therefore by LCT, by limit comparison test, sigma un also convergent. So what is the conclusion? Finally, sigma un is convergent if x less than or equal to 1. Convergent if x less than or equal to 1. Sigma un is convergent if x less than or equal to 1 and divergent if x greater than 1. Divergent if x greater than 1. Now, coming to another problem, seeing this problem. Problem is 1 plus x by 2 plus 2 factorial by 3 square x square plus 3 factorial by 4 cube x cube plus 4 factorial by 5 power 4 x power 4 and so on. 5 power 4 x power 4 and so on. So what is the nth term here? What is the nth term? Un equal to there is no x here, so that means x power 0. Okay, let me delete the first term
By neglecting first.
by neglecting first term. Now tell me what is un. That means treat first term as this
N
x to the power of
factorial.
1 by so this is x power n, right? And 1 factorial, 2 factorial, 3 factorial, so this is n factorial by this is 2 power 1, 3
N
power
plus 1 whole power n.
what?
N plus 1 whole power n.
N plus 1, correct, whole power n, right? This is the nth term. Okay, then since factorials are there, apply ratio test first. N plus 1 factorial x to the power of n plus 1 by n plus 2 whole power n plus 1. So un by un plus 1 is equal to n factorial by n plus 1 factorial, similar terms together, x to the power of n by x to the power of n by x to the power of n plus 1, next into n plus 2 whole power n plus 1 by n plus 1 whole power n, that is equal to, just wait, now this is n factorial. I can write this is n factorial into n plus 1. This is 1 by x into, take n common, n to the power of n plus 1, 1 plus 2 by n whole power n plus 1 by n power n, 1 plus 1 by n whole power n. Okay, here n factorial gets cancelled and I can write this is 1 by n common, 1 plus 1 by n, 1 by x, n power n gets cancelled, 1 n will be there, 1 plus 2 by n whole power n plus 1 by 1 plus 1 by n whole power n. So this n gets cancelled. Now apply limit un over un plus 1 as n tends to infinity is equal to, this is 1 by 1 plus 0 and this is 1 by x, right? And limit value for this, limit n tends to infinity, I will write like this, this one 1 plus 2 by n whole power n into 1 plus 2 by n by 1 plus 1 by n whole power n, 1 plus 1 by n whole power n. So this is 1 by x and you know this formula, limit n tends to infinity, 1 plus 1 by n whole power n is value e, and another formula, limit n tends to infinity, 1 plus a by n whole power n is what? E power a, right? So for this the limit value is what? E square, isn't it? And this is 1 plus 0 by denominator e, denominator e. Any corrections? So this is finally e by x is the value. This is the value of L. This is the value of L. Then, therefore, by ratio test. Therefore, by ratio test, sigma un convergent if L value e by x greater than 1. So x less than e. Divergent if I will write directly here, divergent if e by x less than 1, so x greater than e. Now test fails, ratio test fails, if L equal to 1, that means x equal to e, when x equal to e. Now when x equal to e, see, limit of un by un plus 1 contains what terms? Exponential terms. Therefore, clearly write down here, since un by un plus 1 contains e term, apply logarithmic test. Okay. Therefore, what is this one? When x equal to e, at x equal to e, what is un by un plus 1 is equal to, at x equal to e, un by un plus 1 equal to what? What I have? Yeah, this is un by un plus 1, and this is x equal to e. So you write, actually, let me write. What is this value? At x equal to e, this is 1 by e you will get, and here you will get 1 plus 2 by n whole power n plus 1 by 1 plus 1 by n whole power n. Whole power n plus 1 is there, I think. When x equal to e, right, this value, yeah, whole power n plus 1, and this is only n only is there, n term is there, right? So n term, already it is there now. So sorry, you consider this un by un plus 1, this term is there. See, un by un plus 1 is, I forgot this to write. What is this? Actual original term is this. Before applying the limit, we have this term. So what is finally? This is 1 by e, 1 plus 2 by n whole power n plus 1 by 1 plus 1 by n whole power n plus 1. All of you, once again, when x equal to e, this is my main. Without applying limit value, here we applied limit. Without applying limit, un by un plus 1 value is this entire part, this one and this one. Okay, I'm using that. When x equal to e, the next step is, this is un over un plus 1. Now I have to apply logarithm. Log of un by un plus 1 is equal to logarithmic test. Now 1 by 1. So log of, I will write like this, 1 plus 2 by n whole power n plus 1 by 1 plus 1 by n whole power n plus 1 into e. Log m by n, log m minus log n. So log 1 plus 2 by n whole power n plus 1 minus log 1 plus 1 by n whole power n plus 1 minus one more term is there, e. So minus log e, right? All are to the base e only. So this is n plus 1 into log of 1 plus 2 over n minus n plus 1 into log of 1 plus 1 by n, and log e to the base e value 1. And in the first two terms, n plus 1 is the common. So the terms becomes log 1 plus 2 by n minus log 1 plus 1 by n, and this minus 1. And what is the expansion of log 1 plus x expansion? Log 1 plus x expansion, x minus x square by 2 plus x cube by 3 minus, and so on. Let me apply here that formula, series expansion. log, this is x value, log 1 plus x value. For the first term, log 1 plus x means what? X, that is 2 by n minus x square 4 by n square by 2 into 2 plus x cube 8 by 3 already there, n cube, and so on. Next, minus, this is the next one. X value is 1 by n, x minus x square by 2, that is this one, plus x cube by 3, this, and so on. Everything is over, bracket close, and minus 1 will be there. Minus 1 will be there. That is equal to n plus 1. Now, similar terms, 2 by n, 1 by n. 2 by n minus 1 by n, 1 by n will be there. Next one. Minus, this is, I can write, yeah, minus 4 by 2n square plus 1 by 2n square. That means minus 3 by 2n square. Keep LCM as usual, 2n square plus 8. This is 8 and this is minus 1, means 7 by 3n cube, and so on. And so on, minus 1 will be there. Minus 1. Next step is, this is, you take this 1 common. Here 1 by n common. So the here n common, 1 plus 1 by n. N common, 1 plus 1 by n. By n, 1 by n is common. So this is 1. I think it is clear, right? Okay, let me try. This is 1 minus, this is 1 by n is common. So 3 by 2n plus 7 by 3n square, and so on. This is minus 1. This n, no need, I think, because we have to multiply it by n, no? So no need of this step. Let me check once again. So this is log. Now, what is this? I have to multiply by n. Log of un by un plus 1. N into this one. So this n plus 1. Take that n inside. That is 1 minus 3 by 2n. 1 minus 3 by 2n. Next, plus 7 by 3n square, and so on, and so on. This is multiplied by n now. So this is minus n you will get. Minus n you will get. Any doubts? That is equal to. Now take n plus 1 inside. Take n plus 1 inside. So this is n plus 1 minus, right, n plus 1. Next, 3 into n plus 1 by 2n plus 7 into n plus 1 by 3n square, and so on, and minus n. So now this plus n minus n gets cancelled. Plus n minus n gets cancelled. Now what are the terms? This is 1 minus, okay, 1 minus, I can write 3n. Shall I take n common? Yeah, 3n, because I have to apply n tends to infinity, by 2n plus 7n 1 plus 1 by n by 3n square, and so on, and so on. So this is equal to this n gets cancelled, right? So this is 1 minus, this is 3 by 2. 1 minus 3 by 2 minus 3 by n. 3 by 2n. Next, plus 7 into 1 plus 1 by n by 3n square, and so on. This is the value of n into log.
3n, sir.
Yes?
3n, sir, that is.
Where?
In the last step, sir, denominator. N gets cancelled.
Denominator.
3n. 7 into 1 plus 1 by n by 3n.
7 by 3n cube, na?
Yes, sir. Last step, sir.
Last step. n common 3n, na?
Yes, sir.
Okay, right.
Thank
Now
you, sir.
apply limit value. Limit n into log un by un plus 1 as n tends to infinity. This is what this is the constant minus 1 by 2, and every term in denominator n is there, so 0. This is the value of L. This is the value of L. It is less than 1. It is less than 1. Therefore, by logarithmic test, sigma un is what? Divergent. Lastly, conclusion. Sigma un is convergent. Sigma un is convergent when x less than e. If x less than e, and divergent if x greater than or equal to e. Divergent if x greater than or equal to e. Next problem.
Sir, in this question, we neglected the first term, no, sir?
Yeah.
Sir, we can get the general term by not neglecting the first term, sir.
No. It is possible, no? It's a property of series, no? You can delete
Yes,
or
sir.
add some finite number of terms.
Yes, sir. But not deleting also we can get the general term, sir, in this question.
Yeah. Why you? If you not delete the first term, you will get n minus 1 terms, right? X power
Yes,
n
sir.
minus 1 like that. So
Yes,
to
sir.
avoid that complexity, you can delete. No problem. You can do.
Okay, sir.
If you will get the nth term by considering first term, you can do. No problem.
Okay, sir.
Okay. Right. What is the another one? Shall I stop Rabee'S and logarithmic? Shall I go for another test? You want more?
Give us problems, we will do
Problems?
as assignment
Yeah.
or
I will give
homework.
assignment. I will give assignment. So I'm going for another test. Okay.
Okay, sir.
Okay,
Right.
sir.
Okay. Next one is Cauchy's nth root test. Cauchy's nth root test, or simply it is called nth root test. Statement is, if sigma un is positive term series such that un power 1 by n and limit n tends to infinity. What is that? Nth root of un. Limit n tends to infinity, un power 1 by n. Nth root of un is L, such that limit, what is L value? It is the limit of nth root of nth term, L. Then sigma un is convergent. Sigma un is convergent if, first point, this is sigma un is convergent if L less than 1. If L less than 1. Sigma un divergent if L greater than 1. Third point, test fails. Test fails if L equal to 1. Test fails if L equal to 1. And the hint is, when we have to apply nth root test, if un contains exponents in terms of n's, or un contains powers as function of n, then apply nth root test. What is that? This un, it must be something whole power n, function n, or n square, or 1 by n, whatever it is. The exponent must be, exponent of the nth term must be function of n. Then you apply nth root test. And remember, nth root test here, convergent when L less than 1, divergent when L greater than 1, reverse to ratio test. Okay. Now one problem based on nth root test. Test the convergence of the series sigma 1 plus 1 by root n. 1 plus 1 by root n whole to the power of minus n power 3 by 2. Minus n power 3 by 2. Test the convergence of this series. Solution. The nth term is what? 1 plus 1 by root n whole power minus n power 3 by 2. So one can write this is 1 plus 1 by root n n power 3 by 2. N power 3 by 2. Now what is this one? Since exponent, for this one exponent is a function of n, apply nth root test. So take power 1 by n. Take power 1 by n. So this is 1 plus 1 by root n. What is this becomes? N power 3 by 2 by root n you will get, by n you will get. By n. If you are not getting this, one can write like this. This whole power 1 by n. Whole power 1 by n. So this is 1 by 1 plus 1 by root n. N power 3 by 2 by n you will get. By n. That is equal to 1 by 1 plus 1 by root n. And what is this is? Power 1 means you will get n power half. That means you will get root n. This is the value. Now what is the apply? When apply limit n tends to infinity, un power 1 by n. What is this value? Limit n tends to infinity of what? 1 plus 1 by root n power root n. What is this value? E. What is this value? E. So this value is 1 by e means what? Less than 1. 1 by e means less than 1. Therefore, by nth root test, sigma un is less than 1 means what? Convergent. Sigma un is convergent. This is one problem. And another one is test the convergence of the series sigma n plus 1 whole power n x to the power of n by n power n plus 1. N power n plus 1. Solution. What is the nth term? This is n plus 1 whole power n x to the power of n by n to the power of n plus 1. And coming to this problem, see clearly x power n is there. As n increases, the powers of x also increases. So one can we can apply ratio test. Okay. Now another point is here, the nth term. In an nth term, all powers are functions of n. All powers are functions of n. Therefore, you must apply Cauchy's nth root test. Cauchy's nth root test. So for that, now nth root of this is what? N plus 1 you will get, x you will get, and this is n power n plus 1 by n. So this is n common 1 plus 1 by n into x by you will get n power 1 plus 1 by n. N power 1 plus 1 by n. So un power 1 by n is 1 n gets cancelled. You will get 1 plus 1 by n whole power x by n power 1 by n. This is n not x. N power 1 by n. If I apply the limit n tends to infinity, this is 1 plus 0 you will get, and this is x. And what is this one? Something power 1 by infinity. This is 0. So you will get 1 here. This is x value of L. This is x value of L. Limit n tends to infinity, n power 1 by n value is 1. You can prove this your intermediate techniques. Okay. Using L'Hospital rule or indeterminate forms. Indeterminate forms. This value is L. Therefore, by nth root test, sigma un is convergent if x less than 1, divergent if x greater than 1, right? And test fails if x equal to 1. Test fails if x equal to 1. Now let us deal with at x equal to 1. What is the nth term? What is the nth term? N plus 1 whole power n by n plus 1 whole power n by n to the power of n plus 1, n to the power of n plus 1. So if I take n common, 1 plus 1 by n whole power n by n power n into n power n into n. So this one gets cancelled, right? N power n into n. Then what is un equal to? This is 1 by n into 1 plus 1 by n whole power n, right? Therefore, choose this term, choose Vn as 1 by n. So sigma Vn equal to sigma 1 by n power p, p value 1 is divergent series. Sigma 1 by n is divergent. Now apply limit comparison test. Un by Vn is equal to limit 1 plus 1 by n whole power n as n tends to infinity. This value e not equal to 0 and finite. Not equal to 0 and finite. Therefore, by LCT, sigma un also divergent. Sigma un also divergent. Finally, conclusion. Sigma un is convergent if x less than 1, divergent if x greater than or equal to 1. This is one model. And next one, I will tell one more problem. You take this. Test the convergence of the series 2 square by 1 square minus 2 by 1 whole power minus 1 plus 3 cube by 2 cube minus 3 by 2 whole power minus 2 plus 4 power 4 by 3 power 4 minus 4 by 3 whole power minus 3 and so on. Whole power minus 3 and so on. Solution. What is the nth term? What is the nth term? Un equal to, this is the first term. In the first term, 2 by 1, 2 by 1 is there. So first term 2 by 1 means you have to consider n plus 1 by n, and power 2 is here. So this is n plus 1. Here also n plus 1.
N plus 1.
N plus 1 by n. This whole power what?
Minus n. Minus n.
Minus n.
Term minus 1, second term minus 2, third term. So nth term minus n. Minus n. Is it correct?
Yes, sir.
Yes, sir.
Yes, yes, right. Now, since exponent is a function of n, you have to apply nth root test. Un power 1 by n. So this value is n plus 1 by n power n plus 1, n plus 1, this whole power minus 1. Now take, since we have to apply n tends to infinity, take n terms common. So this is n power n plus 1, n common, outside it is n power n plus 1 by n power n plus 1. Here n common, 1 plus 1 by n by n. This whole power minus 1. So this terms gets cancelled. And for the remaining terms, if I apply limit n tends to infinity, limit n tends to infinity for what? 1 plus 1 by n whole power n. Whenever this structure is there, separate this. So I'm separating this n plus 1 as 1 plus 1 by n whole power n into 1 plus 1 by n minus 1 plus 1 by n whole power minus 1. Don't forget this whole power minus 1. So this first term is e, and this is 1 plus 0, and this is 1 plus 0 whole power minus 1. Next one is, this is e minus 1 whole power minus 1. That is 1 by e minus 1 less than 1. Therefore, by root test, nth root test, by nth root test, sigma un is what? Convergent. Sigma un is what? Convergent. This is one problem. Right. Next one. Now you take assignment. First one. sigma 1 by log n whole power n. Second one, sigma n by n plus 1 whole n square. Third one, 1 plus x by 2 x square by 3 square x cube by 4 cube and so on, where x greater than 0. Fourth one, sigma 2n plus 1 into 2n plus 1 into x, this whole power n by n to the power of n plus 1, n to the power of n plus 1. And fifth one, 3 by 4 x plus 4 by 5 whole square x square plus 5 by 6 whole cube x cube and so on, where x greater than 0. And sixth one, sixth one, I think already we did that. Take this, x by 1 plus 1 by 2 x cube by 2 plus 1 into 3 by 2 into 4 x power 5 by 5, wait, this is 3, x cube by 3, 5, plus 1 into 3 into 5 by 2 into 4 into 6, x power 7 by 7 and so on. X is positive, greater than 0. Seventh one, you take this, 1 square by 4 square plus 1 square into 5 square. Okay, for some problems it is not applicable. So see, not only limit comparison test, ratio test, Rabee'S test, logarithmic test, Cauchy's Nth root test, there are so many other techniques also there. Gauss test, Descartes test, some 3 or more tests are there which are not included in our syllabus. So when test fails, for example, when ratio test fails, we go for Rabee'S test or logarithmic test. When both Rabee'S and logarithmic also fails, then we have to go for those tests which are not in syllabus. So we are not dealing with those problems. We are dealing with within syllabus problems. Now take this, a plus x by 1 factorial plus a plus 2x whole square by 2 factorial plus a plus 3x whole cube by 3 factorial and so on. Another one, eighth one, 1 plus a by b x plus a into a plus 1 by b into b plus 1 x square, a into a plus 1 a plus 2 by b into b plus 1 b plus 2 x cube and so on. Here a, b both are positive as well as x greater than 0. X greater than 0. And the last one more problem, ninth one. I think I have given that. You solve this. 1 plus, both are same, no problem. 1 plus 2 by 3x plus 2 into 3 by 3 into 5 x square plus 2, 3, 4 by 3, 5, 7 x power 3 and so on and so on. Okay, solve these 9 problems, assignment problems. Okay. With this, positive term series are finished. Positive term series test finished. Next topic is alternate series. Alternate series. Okay, in this one we have one Leibniz test. First one, Leibniz test. Second one, absolute convergence, and and third one, conditional convergent. Okay, one more hour. That's enough to complete alternate series. With this, the sequence and series chapter will complete. Check any doubts now.